Welcome. Good evening. My name is Mark Littleton from the University of Guelph. I work in science communication, and that means I'm interested in everything that everybody's doing. Please be friendly, say hi. I'm beginning tonight with a land of reflection. We come in peace. Last night, I was walking on campus and I came upon two bunnies and a hare, and the four of us walked along. And I was one of the land. And then they said, we are on the treaty lands and territory of the Mississauga, the Credit, the Haudenosaunee, and the Anishinaabe. The University of Guelph adds our collective voices to the call to action from Canada's Truth and Reconciliation Committee to hold governments and colonial forces accountable and to seek redress and healing from injustice. From coast to coast to coast, we acknowledge the ancestral and unceded territory of all the Inuit, Métis, and First Nations people. Today, we're working towards community building and establishing trust. We reaffirm our commitment to and responsibility for improving relationships among nations and learning about local Indigenous peoples and their culture. What a privilege it is to stand here before you today. Welcome. Thank you.
Thank you, Mark. So I'm going to ask a quick question. There's the tech person. Who is our tech person this evening?
Ross here.
Oh, you are? Okay. So is Satchin going to is Dr. Panda going to use that? Oh, you have that. Okay, perfect. So I'm going to tell you a little bit about who's here today. So this began as a venture of the Canadian Society for Chronobiology, and this is a not-for-profit society. It's a scientific society that unites Canadian researchers. And part of our mandate originally was to communicate science not just to ourselves, but to the public in general as well. And so we work to bring these ideas in a tangible way through doing talks like this. In addition, today is Cardiovascular Research Day for our research center at the University of Guelph. So we've been very fortunate to pair these two ideas with our public speaker today, who has very graciously agreed, Dr. Satchin Panda, to not only talk about his groundbreaking work in chronobiology and how it applies to humans, but to put that cardiovascular twist on it as well. In addition to those two groups, we've reached out to the public, and we have two special groups here as well as we've put it through Twitter, and if you don't belong to either of these groups, you're welcome to join them as well, probably age dependent. We have people from the high schools in the city of Guelph who are interested in science, and their presidents are going to come up in a minute and tell you who they are and do the introduction. And we also have Dr. Joanne O'Meara, who is a physics professor at the University of Guelph and runs something called Royal City Science, where she creates events all across the city and different venues in order to bring science to people in Guelph. So I'll call her up in just a second. One thing I want to say is if you are CSC or CCBI or you're a member of our trainee events that are going on this evening, I'm going to ask after this lecture that you'll all walk across the street over to the Art Gallery of Guelph with us for some dinner. And the rest of you, thank you so much for joining us. Okay, so with that, I'm going to bring up Joanne, Dr. O'Meara.
Good evening, everyone. I will keep this very brief. So as Dr. Martino said, I am Joanne O'Meara. I'm a physics professor at the University of Guelph, and I am also the co-founder of a nonprofit organization called Royal City Science. We're also now a registered charity. We founded in 2020 with the ultimate goal of building a new science center for Southwestern Ontario. Who thinks that's a good idea? So in our efforts to advance this goal, we're doing three things. We're doing programming all around town. We're doing lots of grant writing, looking for funding and looking for sponsors. And we're also doing a lot of advocacy work, talking to politicians and corporations to get support behind this initiative. So if you want to learn more about the activities that we're running for adults and for kids, you can follow us on social media or on Twitter or on Instagram. You can go to our website and sign up for our newsletter, and you'll hear about all of the activities that we're planning. And thank you so much. If you heard about this through our organization, we're so happy that you came out tonight. And I'm very much looking forward to the guest speaker and learning more about this very interesting subject. Thank you.
Good afternoon, everyone. My name is Vanessa.
My name is Karina.
And we are both grade 12 IB students at Bishop Macdonell Catholic High School who are invited to introduce today's guest speaker. We've both taken interest in medicine and healthcare throughout high school and hope to continue our education and obtain careers in medicine. We're the presidents of the HOSA Club at our school, which is a student organization that explores all aspects of healthcare and offers extraordinary opportunities for students who are planning to pursue healthcare opportunities. Dr. Satchin Panda, PhD, is a professor at the Salk Institute in California, where his research focuses on the circadian regulation of behavior, physiology, and metabolism in model organisms and in humans. Dr. Panda discovered a blue light sensing cell type in the retina and trains our master circadian clock, affects mood, and regulates the production of the sleep hormone melatonin.
Recently, he discovered that maintaining a daily feed fasting cycle, popularly known as time-restricted feeding, that it can prevent and reverse metabolic diseases. Based on a feasibility study in humans, his lab is currently carrying out a smartphone-based study to assess the extent of circadian disruption among adults. Dr. Panda has received the Julie Martin Mid-Career Award in Aging Research, the Dana Foundation Award in Brain and Immune System Imaging, and was a Pew Scholar in Biomedical Sciences. His talk today is titled Timing of Diet, Sleep, and Exercise to Optimize Health.
Thank you. I'm super excited to be here. As you can imagine, I'm from India, but when I came to North America, my first landing spot was Winnipeg, Manitoba. I spent one winter, so that's 9 months in Winnipeg, and that made me an honorary Canadian. So glad to be back home. And before I start, I would like to thank the current and past lab members and also my collaborators, funding agencies, and here is my disclosure. Written a couple of books. So the big question for all clinicians and biomedical research is this: to live at our peak physical, emotional, and intellectual performance, irrespective of age, gender, ethnicity, or health status, is a universal human right and also a human aspiration. We all want to be at our peak performance right now, at every stage of our life. And if you're a kid, then your peak performance may be doing well in school. If you're a young adult, then maybe getting a better job and also stay fit so that you can actually start a good, healthy family. Or if you're older adults, then peak performance might mean being free from all kinds of age-related disease so that you can actually enjoy the fruit of your long working life. And the biggest challenge is, irrespective of what stage of our life we are, we can't actually live at our peak performance, and also we cannot live a long, healthy life. And the question is why? And then the answers may be many different causes, but I would put them in 4 major buckets. One is infectious disease. We all experienced that pandemic, but at the same time there are a lot of other infectious diseases. And metabolic and chronic disease that goes from diabetes, obesity, all the way to cancer. And brain health condition, we often forget that starting from teenagers, even middle school students, all the way to adults and older adults, we do experience various stages of brain health issues. And in fact, nearly 88% of people, at least once in their lifetime, they would experience clinical sign of some brain health issues, although they may not end up in hospital or may not see a doctor. And finally, injuries. So when I turned 50, I realized that the reason why I cannot perform physically is some injuries. And as we get older, we accumulate injuries. So these are the four major buckets why we cannot live longer, a long, healthy life. And in fact, the stats also tell us so. So for example, nearly 50% of adults in the US suffer from hypertension or high blood pressure. Pre-diabetes or diabetes affect almost half of the adult population. Liver disease will affect 1 in 3 adults. In our lifetime, 42% of us will be diagnosed with cancer. As I said, clinical sign of depression or anxiety and getting treated, that affect nearly 50% of people in their entire lifetime. Digestive issues, injuries affect roughly half. Lung diseases, although this was supposed to be 20-30%, what we experienced in COVID is more than that. And the treatments, the medical treatments are not looking good either, because for every person they do have, the 10 highest grossing drugs in the United States fail to improve the health of between 3 and 24 people who take the drug. So don't think that if you fall sick, there is a drug that has a 100% chance that it can cure you. So that's why the best thing to do is to prevent falling sick. But at the same time, an ideal longevity plan or ideal way to live long, healthy life is to come up with a practice or come up with whatever you want to do, personalized lifestyle, personalized whatever it is. It should be able to prevent disease and should be able to solve multiple different issues, starting from infection to injuries. And accelerate cure, once you fall sick and you have to take medication, then prognosis should be accelerated by this plan, and then quick return to full function. We know that there are, for example, there are nearly 15 million people who are cancer survivors in North America and then don't always come back to full function. Similarly, millions of people also suffer from heart disease and they cannot come back to full functionality. And the challenge is that we will at some point fall sick, but can we come back and be resilient enough? And in that context, I guess we need a unifying principle or theory or a framework to work on all of this. And in that context, I would say that circadian rhythm, many of you may not have heard, is actually the ultimate sign of vitality, health, and healthy aging. And aging actually starts from the time we get born. So those younger people in the audience do not think that healthy aging is only for people like me and older. So what I'll do is, throughout this topic, throughout this presentation, I want you to take away 10 messages. So this is one of them. So when we say of circadian rhythm, the first thing that comes to our mind is timing or a clock. And in fact, the first thing actually comes is sleep. So for those of you who were lucky enough to have gone to bed around 10 o'clock last night, your deepest sleep happened around 2 o'clock, and anticipating waking up, your heart rate began to rise, you started to breathe slightly higher, body temperature rises, and after you wake up, then melatonin, the nightly melatonin levels actually begin to drop even before you wake up, and cortisol levels reaches its peak around the wake up time. Bowel movement is most likely in the first half of the day, and also peak insulin sensitivity happens in the first half of the day. High alertness actually happens in the around noon time, and this is the best time for muscle performance. And since alertness goes down, maybe that's why there are 4 different screens in case you get distracted. And then in the evening, melatonin begins to rise, our body temperature cools down, and we go back to sleep. So in fact, if we think about the ideal circadian healthy day, is a day when we have all of these things happening at the right time and right sequence. And of course, this is just the tip of the iceberg, but there are many more things. But how do we connect this to what we have been told about the 3 foundations of health? And those 3 foundations of health are sleep, exercise, and physical activity. And research over the last 25 to 30 years also showing that the circadian clock reciprocally regulates sleep, physical activity, and nutrition. So that means nutrition timing, physical activity timing, and sleep mistiming can directly or indirectly affect the clock. And we do have what we call homeostat. So for example, if we sleep less than say 6 or 7 hours, then next day we can get rebound sleep because our body wants to come back to that homeostatic point of 7 to 8 hours of sleep. Similarly, if you fast for 1 or 2 days, then you are hungry the next day, and we still don't know whether there is an activity homeostat, but people, particularly athletes who regularly exercise, if they don't exercise, they want to come back. So I would strongly argue that there are 3 homeostats, and these 3 homeostats are reciprocally regulated by circadian clock. They also interact with each other, and then the whole system is also under light and darkness. And what is the function of all these 5-6 factors working together? Because when they work together at the right time, then we have optimum immune function, so that improves our resilience against infectious disease. Optimum repair, so that almost every day we do actually injure ourselves, even though you may not experience it. For example, our gut lining is injured almost every single day. Our epithelium cells or the skin cells are getting injured and turned over, and optimum circadian rhythm helps that repair process. And we also know that, and those of you who might have experienced, even few days of sleep disruption can affect your optimum brain health. So having a strong circadian rhythm will actually improve emotional and intellectual performance. And finally, optimum timing of nutrition and exercise can also optimize metabolism and detoxification. Then the question is, what are the circadian rhythms? How are they regulated, and what are they? So the next take-home message is circadian rhythms are controlled by what we call circadian clock. The word circadian means near 24 hours. So these are the clocks that are present in almost every organ and actually in every cell in our body, and they produce this 24 hours timing cue. Although we think that there is a master clock, or we always connect to brain as the master controller of everything, and in fact there is a master clock in the brain, but there are also clocks distributed throughout every organ and even in our hair follicle and skin. So when these clocks work together, then we have daily rhythms in physiology, metabolism, behavior, and even our gut microbiome also shows some sign of 24 hours rhythm. And all of these are connected to the outside world through light, primarily perceived through the retina. So it's not that when you go outside and get a sunburn or expose your skin to a lot of sun to get vitamin D, that works, but it has very minimal impact on circadian clock. The only light signal that matters in this case is through the eye. And then the question is, what are the major advantages of having a clock? Because although I said that clock regulates all these processes, can make us more immune, can make us can optimize health, but what are the fundamental reasons why we have clock? One thing is anticipation. In daily life, when we have a clock, for example, if your class starts at 8 o'clock in the morning, if you know it's 7:45, you get ready. So clocks similarly tell our body when to wake up. So anticipating when to wake up, our body prepares. Synchronization, for example, similar activities have to be done together. So when you make a daily schedule or calendar, if you're going to the shop, then you got to purchase everything and run a few errands together. Similarly, our body also does a lot of things together. And then separation. For example, you don't want to have maximum muscle tone in the middle of your sleep, otherwise you'd be sleepwalking. Similarly, you should not be feeling super hungry in the middle of your sleep. That is also not so good. And gating, for example, during the daytime, even little noises can attract your attention, whereas at nighttime, many of our sensory systems are modulated so that we can go through good night of sleep, even with tiny disturbances around us. And I will not go into the last two reasons. So this is, broadly speaking, these are the major advantages of having a having a clock, whether it's in your daily life or even in your body. Then the question is, well, we know that there are clocks, then what do they regulate? Because we know about hormones, we know about brain chemicals or neurotransmitters, enzyme, etc. The bottom line is almost every hormone, every neurotransmitter, brain chemical, enzyme, digestive enzyme, for example, even every single gene rises and falls at certain time of the day or night. And how do we know that? There are many studies in this area, starting from mice and now all the way to now humans. But a few years ago, we did a very simple experiment. We went, it took us 5 years to get all the permits to do this ethically. So we collected 64 different tissue samples, including 22 different brain regions from young male baboons in every 2 hours over 24 hours, and did RNA sequencing, essentially to see signatures whether the gene is turned on and is making DNA to RNA, so that's the first step of genes translating the information to physiology, metabolism, or behavior. The bottom line is almost every tissue that we looked at had its own set of what we call cycling transcripts. So that means these genes were turning on and off at different time of the day. Some tissues might have thousands of genes turning on and off at different time of the day, and some had few hundred. And then if we combine all of them and ask, is there a whole body rhythm, what we found in baboons who were actually fed only 2 meals, and in fact all over the world, all the non-human primate in captivity and also in zoo, animals are fed in a very defined way, so they were getting 2 different meals. This is their body temperature rhythm. Our body temperature also cycles between day and night, and that's the cortisol or stress hormone rhythm. This is one indicator that they do have this nice diurnal rhythm. And then this is the activity rhythm. Baboons, just like us, tend to take a mid-noon siesta, so that's why you see the dip in activity. But what we found is nearly 11,000 genes rise and reach their peak expression in the late afternoon, whereas at the night time, only few hundred genes reach the peak expression level. Of course, we have to go and figure out what would they do, but the bottom line is just like we go to sleep, our genome also goes to sleep, or the transcription process actually slows down at night time. Then if we ask, okay, so these genes are now cycling and all this stuff, and there are 64 different tissues. Of course, every tissue will have slightly different or overlapping set of genes. If we ask, okay, so what are the genes that are cycling in 20 or more different organs, including brain regions, so they are more likely to be more reliable, then what do they do? Because nowadays we can go from the gene name to what function they play. And if we look at the function they play in genes that are cycling in 20 or more tissues, then what we find is almost everything very foundational in cell biology that is linked to any disease seems to be circadianly or seems to have a 24-hour rhythm, starting from mitochondria function, which is the energy powerhouse of the cell, and also it's a signaling hub inside the cell, to redox, detoxification, protein folding, immune response, and cell secretion. That means every cell secretes something. Even your connective tissue, even your muscle is secreting the glue that keeps the cells together. And then intercellular signaling, so that means many hormones, many neurotransmitters, many cytokines, immune mediators are also circadian. And DNA damage repair. So for example, when you have damaged DNA during the daytime by exposure to bright daylight or sunlight, then that damage is actually repaired in a circadian pattern in the evening. And the circadian clock also tells our cells when to divide. That means when the circadian regulation is gone, then the cells can begin to divide much faster, and that may be one reason why circadian disruption can lead to increased risk for cancer. And finally, nutrient management, how hungry we are, how much we eat, how that food is digested, how that food is converted to different components of our body is also circadian. And then if we know these are very important processes and this orchestra is keeping the music of our body or the health, then how can we control it? So this is where we got to know what are the factors that actually affect the circadian rhythm. And we always think that light is for safety, but actually depending on the light quality or how much light we have, we can reset our clock. So in this context, I think we human species are very different from all other species by one aspect, and that is controlled use of fire. And this happened almost 120 to 200,000 years ago when our ancestors figured out how to create fire, how to control it in a way that we can actually light up the evening. But so this is a video that I had taken when I was in Africa. These are Maasais. They actually don't have any electricity, so every afternoon, evening, they light this fire to keep the animals away and also bake or grill whatever they have and have a community meal. And in fact, the cradle of civilization started with fireside chat. But at the same time, fire extended our day and also gave us more freedom to go explore new area and also create wealth. So as a result, our modern day life, this is from Cloud Atlas movie, those who are familiar, who have seen this. If you project the cost of digital screens, then by the year 2030, digital screens will be much cheaper than painting your wall or putting redecorating your wall. So it's conceivable that we will be living in digital walls where we will be completely disconnected from outside world, and everything that we do will be governed by these digital screens. And in fact, right now itself, it's happening. So the bottom line is this, that we evolved with circadian clocks that enabled survival in a natural world of approximately 12 hours daylight and approximately 12 hours of darkness. Of course, that changes with season. But at the same time, living outside the natural constraints is the key to creating wealth and enriching cultural life. Because the fireside chat or the explorers that actually explored went to new area. They were not just traveling during daytime, they were navigating through night. And so the challenge is this, we are stuck with the circadian clock that had optimized us for the natural world, but we built an anthropogenic world without paying attention to the circadian principle. So now the biggest challenge is how do we optimize anthropogenic world that can still sustain creating wealth, cultural enrichment, at the same time optimize health. So let's go back to same light theme to see what have we learned from melanopsin, the blue light sensing protein that three different groups simultaneously described its function. Actually, only Ige Provencio discovered it first, but three different groups elucidated its function. So it's present in only 5,000 cells in each retina compared to say 14 million rod and cone cells or even more than that we have to see the outside world. And these cells are hardwired or they are monosynaptically connected to the master clock in our brain. And it has some interesting properties. So this is less sensitive to candlelight and moonlight because candlelight is yellow and moonlight is very dim. So as a result, when our ancestors were lighting up the fire, that firelight was not activating melanopsin. So as a result, the brain was thinking, it was getting darker and would go to sleep. And the melatonin, the nightly hormone, rose at the right time. And during the daytime, melanopsin needs a huge amount of bright light during daytime to be activated. So when our ancestors went outside, bright light synchronized their clock, raised alertness and reduced depression. But these days, as we are glued to rectangular pieces of glowing objects and spend most of our time indoor, then nighttime bright light can activate melanopsin, disrupt our sleep, so that we get poor sleep, and then during daytime we are stuck inside built environment with suboptimal or sub-bright light, and that is also bad for our circadian rhythm. So as a result, we go through insomnia at night time or trying to sleep, and then foggy brain during daytime. And in fact, many students, many high school students, many young adults, they begin their day with a big strong cup of coffee and end their day with a melatonin pill. And of course, it might be quick fix, but when it continues for weeks, months, or years, then what the circadian rhythm science is telling us is the risk for many of the diseases or affective disorders can go up. So that led to the idea of lighting revolution to promote health. And in fact, The Economist few years ago came up with this profound statement that the light therapeutics, why this is profound is this: for the last 200,000 years, we used light and controlled use of fire for safety and to light up the evening. We did not care whether that had an impact on health. For the first time in last 200,000 years, we started to think this discovery of melanopsin and its function is encouraging us to rethink how we use light, because light, flipping a light switch literally flips hormones in our brain. So as a result, then the question is, how much light is healthy? This is, everybody is asking that. And we can kind of summarize to some extent that to treat depression or seasonal affective disorder, you need somewhere between 10,000 lux, around 10,000 lux of light for 15 minutes to 60 minutes. Again, this is debatable, but at least if you go outdoor today, even if it is cloudy, that is 10,000 lux of light. And if it is bright daylight with sunlight, then you can get 100 to 250,000 lux of light. And an average person should get around 1,000 lux of light for 30 minutes or more, and which is equivalent to having your lunch or breakfast next to a large window. And that will give you that 30 minutes of bright light. And at night time, you should have less than 20 lux of light for at least 2 hours before bedtime. 1 lux of light, by the way, is the amount of light your eyes will see if you're sitting in a completely dark room and there is only one candle that is roughly 1.5 feet away from your eyes. So 1 candle, 1.5 foot, or your arm's length, that's the amount of light is 1 lux. And then think about 20 lux of light is roughly a 40-watt bulb facing towards the ceiling and lighting up a regular room. And if you want more light, then use work light, like table lamps. And of course, it's gratifying to see that melanopsin was discovered and its role was began to play out in early 2000, 2002, 2004, 2005. And in fact, no direct recording of melanopsin function was done in human retina up to 2018, 2019. But still, it's gratifying to see that almost every year, 1 billion pieces of rectangular pieces of glowing object, whether it's cell phone or your laptop, are now integrating this night light or night shift feature. So those of you who are not familiar, at least switch on your night shift feature. It's a nudge to end your day and get ready. So this is all soft impact, but still, lighting is a $27 billion industry that accounts for 18% of energy production and consumption throughout the world. And what we'll see is human-centric lighting that will change how we use light based on this principle, some of the principles that we learned from melanopsin. But there is way more focused and therapeutic use of light or darkness. For example, in North America now, 1 in 10 live birth is a preterm baby. So that means in the US alone, out of 3.8 million live births, 380,000 babies are born preterm. And when they're born preterm, they're put into neonatal ICU or NICU. And then the standard of care throughout the world has been to put these babies in constant light in NICU. So this is a group in Mexico City that did a very simple experiment. They randomized roughly 60 preterm babies to continuous light, standard of care, or light dark cycle, 12 hours of light, which is 200, they had 249 lux, 250 lux of light between 7 a.m. and 7 p.m. and roughly 27 lux of light, couple of 40-watt bulbs from 7 p.m. to 7 a.m. In fact, they didn't change the lighting. What they did was they covered kind of a helmet-like structure that you see here in these NICUs. What happened then? The effect was profound. The kids that went through light-dark simulations were released from NICU because they caught up with their growth and developmental mark 13 days earlier than the standard of care. Imagine 13 days and at least in the US 380,000 NICU babies. And one day of NICU care can be somewhere between $10,000 to $15,000. So this itself will pay for all circadian rhythm research done in the last 50 years and also for the next 25 years. And now think about the reduction in healthcare cost if we translate to ICUs. Because in the US alone, 1.7 million patients get sepsis and are admitted to ICU. And we know that although 1.7 million people also get cancer, the mortality rate is extremely high among sepsis patients. Nearly 20% die within 60 days of hospitalization. So there is a huge potential here where managing light-dark cycle and associated clinical practice can have a huge dividend. So that's about light, but many years ago, almost 23 years ago, circadian biologists also figured out that when we eat at the wrong time, then mistiming can make a healthy food junk. We can relate to our regular life. You two are best friends, right? So if you come and knock on a door at 3 o'clock in the morning, you'll not be your best friend. So exactly, so that's what happens. Even though you are trying to eat healthy, if your circadian system is not ready, then your body will react as if you are actually eating junk food, because the mistimed food can disrupt the rhythms in most of the peripheral organs without affecting too much the master circadian clock. So as a result, some organs will think that it's day, some organs might think it's night. And that can lead to daily rhythms in physiology, metabolism, and behavior. And that affects essentially your body's ability to anticipate change, respond to changes, and all those basic principles that I had mentioned. And the question is, well, only maybe shift workers experience this kind of stuff, and not us. So the fifth takeaway message is we all are shift workers, because we all are living the life of astronauts, pilots, doctors, and shift workers. So in a nutshell, if we summarize how our ancestral rhythms were before industrialization up to 150 years ago, our ancestors had access to darkness. What we are lacking is access to darkness at night. And in the evening, they had little access to this firelight. They had good night of sleep, and in fact, there are quite a few studies shown that they get a good quality sleep. The physical activity was pretty high, and then the opportunity to eat was limited because we cannot store food overnight, and also food was not that palatable. So as a result, our ancestors ate maybe 2 or 3 times a day. But in modern rhythms are very different. We continuously live inside built environment. We spend 92% of our time inside a structure, man-made structure. This is based on cell phone, Wi-Fi signal, and other stuff that cell companies collect. And the extra 8% maybe at night time you're walking outside, so it's very little. And as a result, we actually have poor sleep or less sleep, very little physical activity, and our opportunity to eat has expanded. So we are told that your brain cannot work if you don't eat. So as a result, we keep on eating 3 meals a day and then a snack in between. And as a result, almost as long as our eyes are open, our mouth is open. How do we know this? Actually, in collaboration with Horacio de la Iglesia from UW, Horacio has been tracking some Argentinian tobas who have no access to light and also some with access to light. And he puts this active watch that captures the light, physical activity, etc. So this is the this is data from one toba, and this is the time when the person actually supposedly wakes up and gets outside and just gets out of the bed. So there is 5 lux of light, and as you know, 5 candles inside a room, that's the amount of light. That's the first time he sees it. This is the last time he sees 5 candle equivalent light. So even if this person is next to a fire, that will be that dim light. This is the first time 50 lux of light, or the last 50 lux of light, and this is the 500 lux of light when the toba is actually getting out of the heart. And that's the time when the person is actually going to bed. We always think that our ancestors went to bed as soon as the sun went down. No. They actually were lighting up the fire and having some social time before they went to bed. And then this band is actually 45 days standard deviation. So you see how tight this distribution is. And Horacio also put this active watch on Seattle high school students, and this is data from one student, and essentially the student gets up right before the class begins, and you experience that, and then goes to school. So that's why the band is pretty wide, and then this is another student. The bottom line was no student was actually going to bed before 12 o'clock in the morning. So that means there was almost 7 to 8 hours from sunset to going to bed, depending on the season. And also the light exposure was bad, and it gets worse when you go to UCSD, University of California, San Diego. We put the same watch, 100 students, only one student went to bed before 12 o'clock, only 2 days in a week. All 99 students actually. So this is the extent of circadian disruption that we see. The point is, we cannot go turn off the light switch, but we know that these students are getting less sleep. So that's why Horacio did a very simple study where he convinced at least 2 different schools to delay the high school start time by 1 hour. And then he measured their activities, sleep, grades, and tardiness with the old school start time and new school start time. And the bottom line is, we always think that if kids sleep longer, then they would do bad in grades because they're not studying enough. So these kids actually slept 34 minutes extra, and their grades increased 4.5%, and the tardiness went down. So every year from 1950s, US high school students have been losing sleep somewhere between 2 to 10 seconds a year. So that means this simple public health intervention based on circadian rhythm science is actually allowing now students to sleep as much as their grandparents or parents slept. And that study was reproduced, and that led to California passing a law that no California middle school or high school can begin before 8:30 a.m. in the morning. So this is another impact of circadian rhythm research on public health. And this will be equivalent to putting all California kids on at least 2 sleeping pills for the entire year. And once I said that no parents would like to do that, and actually 2 parents came up and said, no, we'd rather put our kids on 5 milligram melatonin every single day for the entire school year. So I'm not saying that. So then the question is, if we live with a broken clock, so what? And then the question is, who are the ones who are actually getting affected by circadian disruption? So if we think about shift work, we know there is night shift work, there is evening shift work, there is morning shift work. But there is no very clear official definition of shift work. International Labour Organization, if you go to the website, it kind of roughly says, based on European laws, that staying awake for more than 2 hours and engaging in some task or work between 10 p.m. and 5 a.m. for at least 50 nights a year. So that's 1 night a week. And that constitutes shift work, because when you stay awake 2 hours extra beyond your habitual sleep time, then your circadian clock is disturbed, and it takes 2 to 3 days to bring you back. So maybe for half of the week you are disrupted. But just imagine, almost every mother goes through this chronic circadian disruption after childbirth. So every mother is a shift worker, except that shift workers get days off. Moms don't. And then social jet lag. So this applies to all the students and young adults, because we tend to go spend some time in the weekend, stay awake for a couple of hours extra, and that can affect almost 40 to 50% of young adults. And nowadays this has been institutionalized, because during COVID, almost all universities and high schools adopted digital tools, and one of the default criteria in digital homework is your homework submission time is midnight. So in many high schools and colleges in the US, Now kids are staying awake till midnight just to submit their homework. I don't know, almost every week is a homework, right? There is a homework every week. And then they relax and go to bed around 1. And then jet lag for people like Frank and I who travel at least few times in a year, we are actually getting that also chronic jet lag, almost like second shift work. And then second-hand shift work, this is something that people don't talk about. Usually, if someone in your family is a shift worker, you would like to stay awake and give company, so there is also second-hand shift work. So if we review last 25, 30 years of literature and ask whether acute or chronic circadian disruption increases the risk for XYZ disease, actually what we found was more than 100 different diseases risk go up. And these are only some sampling, and it affects both babies, newborn babies, all the way to middle-aged and older adults. And I have this impaired growth and development that relates to the NICU, the preterm babies. So this is becoming more important because, as I said, we designed this world, anthropogenic world, without paying attention to circadian rhythm, which is almost like building all the buildings we used to build up to 70s without knowing what is wrong with lead and asbestos. And once we knew, it took us 50 years to redesign our built environment. So similarly, what we are thinking, we are just at the very beginning of the redesigning our modern world to optimize circadian rhythm. And some of the diseases actually affect more than 10% of the respective population. So we're talking about millions of people, so tens of millions of people who can benefit from circadian optimization. And then I'll come to this concept called time-restricted eating, which is popularly known as intermittent fasting, which can prevent and sometimes can reverse chronic disease. The concept can be simplified like this. Every time you eat something, most of our food actually has some carbohydrate, some protein, some fat, and as we eat, a body begins to burn the carb and then store some carb as fat. And this continues with breakfast, lunch, and dinner. And after the last meal, if we have a long overnight fast, then of course I'm exaggerating these curves, but our body will slowly deplete the stored carbohydrate and then will begin to burn some fat. And this nutrient switching also impinges on the circadian clock, and it kind of synchronizes the circadian clock and amplifies its effect. But what is interesting is next day morning, as soon as we eat breakfast, within 15 to 20 minutes, our this fuel burning switches back to burning sugar and storing fat. So now imagine if you take the same number of calories spread over 15-16 hours, then you don't have that prolonged fasting at night time. So as a result, your body cannot do many of the stuff that are associated with, for example, burning fat, and also things that are turned on by the circadian clock because of this signal. So you can imagine that if you take two groups of people, one group gets the same number of calories, eat within 8, 9, 10 hours, and then the other group eats for more than 15 hours, then they might have different outcomes. And we actually did the same experiment in mice. We took mice, young mice, they were born to the same mom in the same room, they had the same gut microbiome, everything was same. They ate the same number of calories and from the same food. The only thing that was different was the first group of mice was allowed to eat whenever they want, so they eat almost 75% of food during nighttime because mice are nocturnal, and 25% of food during daytime. And then this time-restricted eating or time-restricted feeding, where the mice have access to food for 8 to 12 hours, and they eat the same number of calories as the first group. And the first experiment, we did this for 18 weeks. That's the body weight of these two groups of mice that are changing as the weeks go by. And what we found was the first group of mice, average, they were 47 grams at the end of 18 weeks. These were 34 grams. So this is a huge difference, 20 to 30% change in body weight. But not only that, those mice were obese, diabetic, and had all these diseases that actually affect two major causes of death in Western world, cardiovascular disease or cancer. And what was interesting was if we take these mice, which have already become obese, and then put them on time-restricted feeding, we can reverse some, not all, of these bad health markers. Now over the last, so this was done in, the first experiment came out in 2012, 11 years ago. Now these experiments have been repeated many times all over the world in mice, rats, Drosophila, all the lab organisms, and what we find is these are the benefits. Then the question is, how can we translate to humans? So first we have to figure out when people eat and then figure out whether they can change it. So a few years ago, when we were trying to translate this, people would come and say, no, I eat within 12 hours. And I said, really? So let's see whether you really eat within 12 hours. Because what we figured out was nutrition science had never ever tried in the last 100 years of its history a simple thing. When people eat from one day to another day to another day. And we went through a lot of literature. And then first thing is, most nutritionists do not consider that a snack that's less than 25 kilocal should not be considered as food. And that has led to people thinking that the cup of coffee with cream and sugar is not food. But imagine this, an average human like me, I have 5 liters of blood, and my healthy blood sugar level should be 100 milligram per deciliter. So that means if you want to squeeze all this sugar out from my blood, you'll get 5 grams of sugar. And if I take 1 spoon of sugar, that's 5 grams of sugar. And if I consume that 5 grams of sugar and my muscle and my pancreas is not working, then theoretically my blood glucose level should go up to 200 milligram per deciliter, which is diabetic. So that's why what we said was, we don't know whether that 5 gram or 20 gram should be defined as food. So we made an app called My Circadian Clock, and the first study was with 156 people. None of them was a student, because we know that they have disrupted circadian rhythm, and no one was a shift worker. These were mostly people who did 9 to 5 job, and we asked them to do one thing. Open the app, one click, take a picture of your food, second click, press save, third click. They didn't have to say what they ate, what are the portion size or anything, nothing. Just 3 clicks, and the food picture was not actually saved on their phone, it came to our server. And if they forgot, they can go back and say, I ate this, and approximate some time. And every time they ate something that had calorie value above 5 kilocal, because your black coffee has 5 kilocal, Diet Coke has 2 kilocal. So these are only when they have more than 5 kilocal, if we guesstimate. Then, so this is the what we call feedogram, because just like actogram puts activity. You might think that this guy is kind of nuts, he's eating so many times. But take a pause, think how many times you have actually consumed food since morning, not only your major meals, but other meals. And if we combine the food eaten during the weekday and weekend, we also see what we call metabolic jet lag. In the weekend, we tend to eat later during the day. And this person had that. And in fact, many people, almost 70% of our participants had this weekend jet lag in their food intake. And if we combine all of these dots and then put it around the clock, where top is 6 a.m., bottom is 6 p.m., and this is 3 weeks of diet record, just what time they consumed something that had more than 5 kilocalories, this was like this. You might think this is an outlier, but these are 156 people's data. And as expected, the number of events peaks around noon and evening dinner time. And since we had the picture, we put it on Amazon MTurk for people to guesstimate how many calories are there. We can take the average calorie in every picture. And as you would expect, a lunch can have 2 or 3 pictures. So that's why this is average calories per pictures is slightly bumping during noon and dinner time. But the midnight snacks are not, people are not getting up and eating only a quarter cookie or half an apple. They have bowl of ice cream or bowl of Cheerios or something. So what was interesting was the average eating. If we take the average time in which your body is expecting to eat food, I'm not saying about your first meal to last meal every single day, but over last 3 weeks or 2 weeks of data, when your body is likely to expect food, what we find is 50% of adults eat for 14 hours, 45 minutes or longer. We call it 50% of adults eat for 15 hours or longer. Less than 10% of people actually consume all their food within 12 hours. And since we had all the food pictures and guesstimated calories, we can ask, so by noon. So our day starts actually 4 a.m. because many people may eat after midnight. So between 4 a.m. and 12 noon, people consume less than 25% of their food, whereas we know that your pancreas is most active in the first half of the day. By evening, we consume roughly 2/3 of our food that we consume. And then between evening and maybe in the first 3 hours of evening, we consume more food than the first 8 hours of the day. And this has been now repeated in multiple studies, and the outcomes are very similar in different regions, different countries. We also give them a watch so that we can figure out what time they woke up, and we overlay the food. Now we can figure out, after waking up, how much time they're spending before they have their first calorie. And so in the same time, we can have the last calorie and then look at when they went to bed. The bottom line is nearly 80% of people eat or drink something within an hour, within 90 minutes after waking up, and 50% of people eat or drink something 2 hours before going to bed. And we know that these may not be the best thing you should be doing, because in the morning, as our melatonin levels is coming down and cortisol levels are peaking, that's not the best time to eat. Similarly, before going to bed, it's better to fast for 2 to 3 hours for better night's sleep. So then the question is, what should be an ideal circadian day to prevent, manage, or reverse chronic disease? If we combine all the stuff that we talked so far, and maybe more, because I didn't touch upon exercise, I think there are only 6 different rules that you can take away. 1, try to go to bed at a consistent time and try to be in bed for 8 hours so that you can get somewhere between 7 to 7.5 hours of sleep. So, and there are many studies all over the world showing that there is a sweet spot between 6.5 to 7 hours of sleep, which is associated with best health status and outcome. Then after waking up, avoid eating for at least 1 hour after waking up, and this is something that people question me, but I would go by this, that a lot of people who are actually waking up to an alarm clock, that means their melatonin level has not come down to baseline, and it will take another 1 or 2 hours after waking up, and same thing, cortisol levels begin to rise in the morning. So rule number 2 is to avoid food at least for 1 hour. Then have your breakfast or the first meal of the day at a consistent time, because if you change that breakfast time, since that disrupts your circadian clock, that will send confusing signal to the clock. And then after the first calorie, count 8, 9, 10 or maximum 12 hours, and you should eat all your food within that 8 to 12 hours. And I think anyone from 10-year-old to 100-year-old can safely eat everything within 12 hours and may not face any serious medical conditions unless you have type 1 diabetes or genetically predisposed to hypoglycemia. So that's number 3. And then the 4th one is 2 to 3 hours before bedtime, no bright light and no food. And number 5 and 6 is at least have more than 30 minutes of activity and 30 minutes of daylight. Again, afternoon exercise, there is a lot of data coming out showing that afternoon exercise is much better for many things. Those who are athletic, the performance is much better when you practice in the late afternoon because your body is warm, your muscle tone is better, your joint is much better, so your risk for injury is low. Those with hypertension and higher blood glucose, there is some indication now that afternoon exercise is much better than morning exercise at the same quantity and quality in reducing blood pressure and blood sugar. So these are the 6 simple things. And a few years ago, as I mentioned, we asked a very simple thing, that if you're eating for more than 14 hours, can actually people adopt a 10 hours time ratio eating? So this is the eating interval at baseline in red, and the self-selected a 10 hours window, and these are 8 people, and they were not obese, so they had a BMI of less than 30 but more than 25. They lost 3.5% of their body weight at 18 weeks, and then there was no contact with them for a year. They came back after a year, and they still maintained that weight loss. And we were surprised when we asked them. What was surprising to know was they felt more energetic in the morning, and overall their energy level throughout the day was high, and their sleep satisfaction went up. And this is really exciting because in most weight loss intervention, you are told that you have to keep your weight down, but these guys were actually doing it not because of their weight, but how they slept and how they felt more energetic in the morning. You know, sometimes you have to do human studies because our mice never told us that they were more energetic and they were sleeping better. But the challenge is, almost as we cross the age of 60, a lot of us will have metabolic syndrome, which is also a precursor to many cardiovascular disease. Those metabolic syndrome is when you meet 3 out of these 5 different criterias. And the question was, can people with metabolic syndrome adopt time-restricted eating? Because many of these patients have tried diet and exercise, they are already on medication, 1 or more, and this is the kind of experiment that we cannot do in mice. And also this is a small study because this is how feasibility studies are done. So we took 19 patients, 16 were on medications. We asked them, can you eat everything within 10 hours? Self-selected 10 hours. We don't care whether it's 7 a.m. to 5 p.m. or anything else. So, and then they did it for 12 weeks. So this was kind of the study plan. We'll monitor them for 2 weeks in the baseline and then 12 weeks of intervention. They used an app, and we also put a continuous glucose monitor for a couple of weeks, and they also used a active watch. And in fact, the baseline mean eating window was 15 hours. They brought it down to 10 to 11 hours. And the yellow dots are when they were eating at baseline. Blue dots are the last 2 weeks of intervention. Many people compress their eating zone, and typically they delayed their breakfast and also advanced their dinner. So they did both. And what we found was they had a slight drop in systolic blood pressure and also diastolic blood pressure, because sometimes the antihypertensive drugs don't work well to reduce your diastolic blood pressure. Waist circumference reduced, and then total cholesterol reduced, LDL cholesterol reduced, but HDL cholesterol did not rise within at least this 12 weeks intervention. And this is an example where somebody was waking up, was having the breakfast within an hour of waking up, and then going to work because he had a morning job, would drive to work, and then at this is the lunch break, and would come back home and have dinner before 7 o'clock. Nutritionally, no nutritionist would say that this is a bad habit. The only thing he did was delay the breakfast so that he was eating the breakfast at the first coffee break at work. And this is his continuous blood glucose monitor at baseline in orange, and actually he was undiagnosed type 2 diabetic based on the blood work. And just after 12 weeks of intervention, this person was BMI 41. He did not lose too much of weight, lost only 0.7 BMI, but his blood glucose became almost normal. Why this is exciting? In the US right now, there are 92 million people who are pre-diabetic and another 10 million people who are newly diagnosed type 2 diabetic. And if this can delay the onset of type 2 diabetes or reverse their pre-diabetes, then it's a huge saving, because when a pre-diabetic person becomes diabetic, then the average healthcare cost per year, average, for that person goes up to $9,000 a year for the rest of the lifetime. If we can delay that by 1 year in 1 million people, that's $9 billion in saving. Again, that's much more than what NIH and SF combinedly spend on circadian rhythm research in 10 years. So the last part, as I said, nearly 1 in 4 shift workers, working adults is a shift worker. Shift work disrupts circadian rhythm, increases the risk from cardiovascular disease and cancer. And shift workers are almost always excluded from clinical trial, whether it's behavioral intervention or even pharmacological drugs. And shift work lifestyle also dampens the benefit of common drug. The same drug might give you benefit. For example, metformin gives you a lot of benefit for a regular worker, but doesn't do that well for shift workers. And out of 420,000 clinical studies listed on clinicaltrial.gov in 221 countries, less than 400 are on shift workers. And so that's why a few years ago,
when I'm in a fire station, my heart rate, resting heart rate goes up just being in a fire station.
Our schedule is completely different than any other schedule.
For the fire department, you are always in a heightened state of awareness. Over the course of a career, it can really tax your body and mind
And as a consequence of their lifestyle, 45% of on-job deaths of firefighters is attributed to cardiovascular disease.
No one really talks to you about the physiological and psychological effects that has on you.
I pray that I can always fulfill my duty. I took an oath to do that.
Firefighters are a really interesting group of individuals. They still have really early onset cardiometabolic diseases because they have such a strenuous schedule.
Started looking for new ways and new research to see how we could affect our health.
We have to be very, very aggressive in what we do, the research, the information.
Is there a way that we could use what we've learned in circadian biology and see if we can improve firefighter health just by making small changes in lifestyle?
Firefighters in general are always looking for ways of improving their overall health, whether it's physical or mental.
Because what we do for a living is detrimental to our health.
If it doesn't work out, then it doesn't work out. I'm going to go back to the drawing board, but I really think it's a good shot here.
Yeah, so what we did just at the beginning of COVID, with funding from Department of Homeland Security, we did this randomized controlled trial where we had 150 firefighters from San Diego Fire and Rescue. The city actually agreed to engage the firefighters in a clinical trial. There was a huge risk because we asked half of the firefighters to eat within 10 hours, self-selected 10 hours, and in San Diego, firefighters do 24 hours duty. So that means for 14 hours on the job, they're not eating. So the risk was whether the response time would increase, and that would be lives lost or property lost. So we put a CGM, Active Watch, and also the app so that we can monitor what they were eating, when they were eating, and how it was impacting their blood glucose. We also had the light exposure data and then the activity data. And this is the standard of care group, which essentially did not change their eating pattern. And they continued at the end of 3 months, they had similar eating pattern. This is the time-restricted eating group. The red dots are the food they were eating outside their selected, self-selected window at baseline, and they reduced a lot of that food that they were eating outside the window. And this is also a unique study because where we had mixed population, nearly 30% of firefighters were completely healthy, and nearly 70% had at least one cardiometabolic risk factor at baseline. And this is why this is important is if we say everybody should do time restricted eating or circadian optimization, then the pushback is I'm not sick yet. Why should I adopt healthy lifestyle? Because we tend to adopt healthy lifestyle only when we are sick. And since it was a mixed population, actually what we found is firefighters can do this. So they reduce their eating window by 3 to 4 hours. And we always said that firefighters, if they can do it, you can do it. And as a group, the VLDL particle size actually changed to favorable direction. And then there are a few changes that actually changed only in the time-restricted eating group, not in the standard of care for the whole population. But we know that there are people who are at high risk or had a high cardiometabolic risk factor. For example, they had high fasting glucose, high HbA1c or HOMA-IR, or systolic blood pressure, diastolic blood pressure, and those at a higher risk, they actually improved significantly when they did time-restricted eating. So the bottom line is, in this modern world, erratic lifestyle that disrupt our circadian rhythm can bring us closer to many of these chronic diseases, whereas circadian lifestyle that combines light exposure, eating time, sleep, physical activity at the right time can reverse a lot of this disease and can bring us back to normal health if we fall sick and if we have gone through treatment. So thank you, Canada. Thank you, Ontario. Thank you, Southwestern Ontario. And thank you, University of Guelph. And sorry, I went over.
So we're going to go over to eat just a minute, but for those of you who are here from the public, if anybody wants to ask a question, I'm happy to run the microphone over to you. Yes?
Or you can shout from there.
Yeah, I guess I could shout it out. It's a great presentation. I just had a question about the light exposure and the timing of light exposure. So I read a little bit of research on light history and how light in the morning can maybe attenuate any circadian phase shifting effects of the light at night. So would you say that light in the morning, or the intensity of light in the morning, is more important than night or light, or would you say like both of them are probably equally important?
I think the bottom line is a lot of people are not getting enough light. So light, whether in the morning or daytime, is just like exercise. It's much better. But light in the morning has few things. One is it helps reduce your melatonin level. And on a personal basis, what I have seen is when I go out and have the morning light, that is also a very strong resetting signal, and I feel better rest of the day. At the same time, there is also new studies showing daytime bright light exposure also helps increase the nighttime melatonin peak, and that can indirectly improve circadian rhythm. And I guess you can talk to Frank more about controlled light exposure and how it affects it.
Okay, those of you in the conference, actually anyone from U of G who's part of our conference, can you stand up? Okay, those of you in one of our two conferences, please follow these people over to the art gallery of Guelph. The rest of you, thank you so much for coming. And thank you, everyone.